All right, so on the front side of this, we have a function that is in intercept form, and we're going to find all the things and do like a basic graph of it. And so the first thing we're going to find is the degree. So do you guys know how to find the degree whenever it's in factored form? It's not 2. You add the exponents or add the multiplicity, it's 4. So these 2 that you can't see are 1s, so you add 2 plus 1 plus 1, and the degree is 4. Right? Now, I don't think we've done a ton of practice with leading coefficient when it's in factored form, but as long as all of these x's don't have a number in front of them, and I don't think they're going to for what we're doing, the leading coefficient is just going to be the number in the front. So what is that number technically? -1. Good. All right, and then to tell the end behavior, that's all you need is the degree and the leading coefficient. And so on your quiz tomorrow, I'll have the end behavior, like I'll have this stuff already written for you. You just have to fill in the blanks with either positive infinity or negative infinity. You do need to know that as x approaches negative infinity, that is the left side of the graph, and positive infinity is the right as x approaches positive infinity. All right, and then the leading coefficient will always tell you what happens on one of these sides. Do you guys remember which side? Leading coefficient tells you the right side. And so if it's positive, it will be positive infinity on the right. If it's negative like this, it's going to be negative infinity on the right. That's what we learned the last couple of days. How do you figure out the left side? You use the degree. If the degree is even, what do you know about the left side? It's the same as the right. If the degree is odd, the left will be the opposite of the right. All right, and then finding the y-intercept of every function in the entire world, you do the same thing. You put 0 in for x. So basically what we have, negative 3 squared times negative 1 times negative 5. All right, so you got these little calculators in front of you. You can choose to do this in your head if it's easier than doing it on the little calculators. But to get a negative, you actually have to hit the number first and then do a negative. Do you guys know what 3 squared is without doing that on the calculator? It's 9. If you don't know what 3 squared is, there's not a squared button on here. You multiply 3 times 3, you get the 9. And then we'll put this little negative in front. So negative is the very top row, middle button. And what it'll say is like a little minus at the top. And then you're going to multiply that by negative 1. So you do times 1, make it negative. And then times 5 and make it negative. And then equals. Or you could just do this one at a time. It doesn't matter. Did anybody get something that they think is right? It's negative 45. So it'll say like it'll say minus the top left corner when it's negative. It might be easier for you to remember the rules of negatives. When you're multiplying, if you multiply an odd number of negatives, it is going to be a negative answer. An even number of negatives is going to be a positive. All right, so there we go. We got our y-intercept of negative 45. Now let's find our zeros and their multiplicity. So we go back to the factors. If x plus 3 is a factor, what is the 0? Negative 3. And what is its multiplicity? 2. Good, it's whatever that power is, so it's 2. All right, and then we have positive 1 What is its multiplicity? 1, good. And then the last 0 is 5 with a multiplicity of 1. So we practiced those things quite a bit, with the exception of the y-intercept. We probably haven't done that as much as the other things. Okay, now we're going to sketch a graph. Our graph isn't going to be glorious, but it's going to be good enough for what we want to do with it. So on the y-intercept, we need to go all the way down to negative 45. So we're going to have to go by tens. But everywhere else on the graph, we can, I mean, going up, we'll have to go by tens, but going across, we can just go by ones. All right, so we want a y-intercept of negative 45, so in between negative 40 and negative 50. Right, the zeros are going to be x-intercepts, and so we have zeros at negative 3, at 1, and at 5. All right, and then we're going to use our end behavior. And so we know that both of these arrows are going towards infinity. On left and right, we have arrows pointing downward. So I'm just going to do that. Now, are any of these zeros going to have something special that happens at them? One of them is. On this one, we're going to bounce. So multiplicity of 2, we're going to bounce. All right, so I'm going to start at this left side where this arrow is pointing down. I'm going to connect it. I'm going to go to that 0 and I'm going to bounce. From that bounce, I'm going to go over to my y-intercept. And then I'm going to try to be smooth. So polynomial has smooth, rounded turns, so try to be smooth. All right, and then we're going to curve up, and then we're going to go straight through that 0, and then we're going to curve and go straight through and connect to my other arrow. So try not to be jagged. I mean, it was okay, like if you wanted to go down and then come back up like that, you can, that's fine. So when I'm checking this, I'm just checking you have your intercepts right, that you're bouncing when you're supposed to bounce, that you're bending when you're supposed to bend, and that the arrows are pointing in the right direction. All right, any questions on that? It was super fun, wasn't it? All right, on the back, we're going to do just the opposite. We have the graph. We're still going to find all the things, and in the end, we're going to end up with the equation. Okay, so finding the y-intercept, it's crazy easy when you have the graph. Where does it cross the y-axis? At 4. All right, zeros, still also pretty easy. It's easy on the other side, too. You're just finding the x-intercepts when you're finding the zeros. If it goes straight through like it is going straight through at negative 2, it's a multiplicity of 1. So negative 2 and 1, negative 1, both have multiplicities of 1. But 4 has something fancy. So what do you think the multiplicity is at 4? 3. So when it bends, it has a multiplicity of 3. And when it bounces, it has a multiplicity of 2. It technically could have a multiplicity of 4 or any even, but just to make it easier for us, we're just going to say 2. All right, and behavior is also fairly simple to do when you have the graph. You just have to remember which is the left and which is the right. So as x approaches negative infinity is the left. So I look at the left arrow. Since the left arrow is pointing up, it's going to be positive infinity. And as x approaches positive infinity, that's the right side. That arrow is pointing down, so it's going to be negative infinity. All right, when we're doing the degree, what are we going to add to find the degree? The multiplicities. So we're going to add our multiplicities. This one has a degree of 5. Okay, so on this side, it feels like everything's a little bit easier until you get to this step. This step is probably the most challenging step out of all of the steps. Maybe, maybe not. But to get the leading coefficient, we have to pretty much find the equation. So this one is going to take care of the last 2 blanks. So this is called g of x. All right, so we're going to start off with g of x equals a. A is what we're looking for here. And then for each 0, we are going to do a factor. So this one had 3 zeros that we found earlier. So we're going to have 3 factors. And then if the 0 is -2, do you guys know what the factor is? Positive, so it would be x plus 2. Good job. And for a multiplicity of 1, you technically could put a 1 there, but you don't have to. All right, and then -1, we'll have x plus 1. And then for 4, we'll have x minus 4. What else do we need on that one? A multiplicity of 3. Good job. Okay, so we need to do something so we can figure out what a is. Do you guys remember what we did? It's been a few days. We plugged something in, something we found. The y-intercept. We're going to plug in the y-intercept. So the y-intercept is the point 0, 4. We just gave it as 4 earlier, but it's important you know. The x is 0, the y is 4. So in for g of x, we put 4. And then for all of the x's, we make those 0. So this ends up being 2 times 1 times -4 cubed. All right, let's see if we can get this right on our little baby calculators, because there's not a cube button. So if you want to cube -4, you have to do 4 and then do the little negative, times 4, do the negative, times 4, do the negative, equals. So I'll get -64? Yes. What else do I need to multiply that by? 2. So -128a. All right, and then to figure out a, you're going to divide by that -128. Now I am perfectly fine, especially since we're using these little baby calculators, if you leave it like that. It doesn't matter. You've done the difficult stuff. Simplifying fraction is not a pre-calculus skill. It is an elementary skill. We're not worried about it. We can leave it just like that. I don't care. All right, and then we've done everything all the hard stuff we've done. So all we have to do now to find this last box is take what we got for a and plug it in right there. All right, what questions do you guys have?